Okay, in this Math 2 video, we're going to do Chapter 3, 29 to 31, and just a heads up, this is going to be an extremely long video, so hopefully you have about 20 minutes to spare on this one. Okay, so the first one says something about Edie told Alfred, I bet if I flip you 3 coins, I get exactly 2 heads. I bet that I can get, I'll bet I can get exactly 2 heads if I flip 4 coins. That's easier. No, it's not. It's harder. Who's correct? So show all your work. Okay. This is going to need a tree diagram of some sort because there's no way we're going to be able to do this without a tree diagram. Okay, so we're going to do the first one. I bet if I flip 3 coins, I can get exactly 2 heads. I bet if I can get exactly 2 heads if I flip 4 coins. Okay, so the probability, we're going to have to do 2 tree diagrams. There's no way out of this one. Okay, so what if he bets, okay, he has 3 coins, right? So each coin, you're going to take a coin, okay, and then you flip heads or tails. So here's your heads, here's your tails. And then each one of these branches is you're going to have another flip, right? Heads or tails, right? That's your second flip. Your second coin, and then your next one is going to be heads or tails, heads or tails, heads or tails, heads or tails. Okay, so we have heads or tails, heads or tails, heads, tails. You can speed up if you need to, heads or tails. Okay, now so let's see. We have 50%, right? So 1/2 on each one. Okay, this is flipping 3 coins. And then we have 1/2. Each time you flip a coin, it is still 1/2 and 1/2. And 1/2. Okay, so let's see what we have. We have, we're going to multiply the branches, right? So 1/2 times 1/2 times 1/2 gives us 1 out of 8. 1/2 times 1/2 times 1/2 gives us 1 out of 8. This is 1 out of 8. This is 1 out of 8. All of these are all 3 equally likely, so it's 1 out of 8 chance in each one. Okay, so this one is, the first one is heads. Okay, so heads. This one's heads, tails. This one is heads, tails, heads. You have to follow the branches. Heads, tails, tails. Then we're down to, so we finished everything up here. We have tails, heads, tails, heads, tails, heads, and then tails. Okay, so the probability of getting exactly 2 heads, okay, and only 2 heads. Alright, well, this one is 3 heads, so we don't really need that one. Okay, so that one's not what we want. Exactly 2 heads is this one. Exactly 2 heads is that one. Exactly 2 heads is this one. And that one's tails. 1 head. Okay, so basically 1, 2, 3. So the probability is going to be 3 out of 8 that we actually get 2 heads when we flip 3 coins. Okay, and now you basically need to do the same thing again, but this time with 4 coins. So you're going to have more branches branching off from each of the little tiny branches over here, and then see if it comes out to more than 3/8 or less than 3/8, and see which one is actually harder to do. Okay, that was number 29. All right, number 30. Use a probability area model or tree diagram, or refer to the table you created for the roll and win situation, probably 3-6, which is basically the one that had 1 dice and then spinning another dice. Okay, that represents a sample space for the sum of the numbers when rolling 2 standard 6s dice. So in a casino dice game, in a standard casino dice game, the player wins on the first roll if he rolls a sum of 7 or 11. What is the probability of winning on the first roll? So let's go back to that table. It was a table that looked like this one, right? We did this in the other video. So what's the probability of actually getting a 7 or an 11? Okay, so the probability of getting a 7 was 1, 2, 3, 4, 5, 6. And then with the 11, 6, 7, 8. So that would be 7 out of 8. I'm sorry, oh my goodness. 1, 2, 3, 4, 5, 6, 7, 8. Oh my god, 8 out of 36. I'm going crazy. Okay, so the probability of winning on the first roll is 8 out of 36, better known as, what's 8 divided by 36? Better known as 22.2%, which is actually kind of low. Okay, now the player loses on the first roll if he rolls a 2, a 3, or a 12. What is the probability of losing on the first roll? Okay, so a 2, a 3, or a 12. A 2, a 3, so we have 1, 2, 3 of these guys, and then 4 for the 12. Okay, so 4 out of 36, right? Or better known as what? 1 over 9. So what's 1 divided by 9? Equals approximately 11.1%. So there's actually a lower chance that you're going to lose versus winning, which is good because you want to know. Okay, so if the player rolls any other sum, he continues to roll the dice until the first sum he rolls comes up again, or he rolls a 7, whichever goes first. So what's the probability that the game continues after the first roll? Oh boy. Okay, so it's basically everything that is not a 7 or 11, and everything that is not a 2, 3, or 12. Because if we get any of the other numbers besides 2, 3, 12, or 7 or 11, that means we can spin again, or we can roll again. So we have, what do we have? We have the 4s, the 5s, the 6s. We cannot spin a 7 because otherwise the game is over in the first run. And we won, which is good, but that's not what we want in this problem. The 8s, and the 9s, and the 10s. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. Hopefully that's right. I'm going to take a win and say that's correct. So 24 out of 36 is the probability that we roll something else other than a 7, 11, a 2, 3, or a 12. And that gives us a 66.6% chance that we're going to get to spin again, or roll again. Alright, that was part C. Okay, number 31. We have very different dynamic for this thing, so we'll see how this is going to go. Okay, examine the graph at the right. We have line CM. What's the equation of CM? Okay, so this is going to be in y equals mx plus b. Alright, your slope should be, let's see, 1, 2, 3, 4, 1, 2, so we're going 2 over 4 for your slope. And then your y-intercept is at 1, 2, so plus 2. Okay, or better known as 1/2 x plus 2. Alright, x and y-intercepts. Let's see, the x-intercept is where the line is touching the x-axis, so that's going to be at -4. And then we already know what the y-intercept is. It's at 2, so we're good to go. So your x-intercept is going to be at -4, 0, and your y-intercept is going to be at 0 and 2, right? Because that's where the line touches the x-axis, that's where the line touches the y-axis, and then 1/2 x plus 2 is going to be your equation. Calculate the area and perimeter. Okay, that should be pretty easy to do. Write an equation of the line that's perpendicular to CM. Okay. Area. Let's see, it's a triangle, so area of a triangle is going to give us base times height divided by 2. Your base is 1, 2, 3, 4. Your height is 2 divided by 2. That gives us 8 divided by 2, so we get 4 units squared. There's your area. Your perimeter of your triangle should be 4 plus 2 plus whatever c to m is. So we actually need to calculate this. This is 4, this is 2. The c to m is this part. So we're going to do 2 squared plus 4 squared to find cm squared. So we have 4 plus 16. Was that 20? So the square root of 20 is going to be cm. Okay, so this is the square root of 20. So plus the square root of 20. Anything else that we're missing? No, but we can clean this up. So perimeter of the triangle should be 6 plus square root of 20 units. I'm not going to do it on the calculator right now. So if I just say that's what it's at. Okay, write the equation of the line that passes through point N that's perpendicular to CM. Okay, I'm going to do this the fast way because the perpendicular to it would have to mean that, so perpendicular slope would have to be the opposite and reciprocal slope of the one that you just had. So if your original slope is 1 over 2, your perpendicular slope should be negative 2 over 1. All right? And your equation should look like y equals mx plus b also. And you have a point M that is 2 and 3. Okay, so if M is, I'm going to run out of space in a second here. Where's my sticky notes? There it is. There we go. So if M is going to be negative 2 over 1, okay, your x is going to be 2, your y is going to be 3. So we have 3 equals negative 2 times 2 is negative 4 plus b. So add a 4 to both sides, solve for b. You have 7 equals b. So finally your answer is negative 2 over 1 x plus 7. Okay, and you're good to go. So that is the slope of a line, negative 2x plus 7. And if you go back to your picture, it should look like this. You should hit it at 7, go through M, and then come down the other way. Alright, and then where they meet should create a 90-degree angle because those two lines have opposite and reciprocal slopes to each other, so that means that they're perpendicular to each other. Alright, and then the last one is 32, which is, I think, outcomes. Yep, okay, 32. Congratulations, you're going to be contestant on a new game show with a chance to win some money. So you will spin 2 spinners shown below to see how much money you win. If you spin, okay, this is going to be kind of fun. If you spin $100, right? Okay, you spend $100, and on your next spin, you either get to keep your winnings or double your winnings. You get $1,500, you get to keep your money or double, and then $300 you get to keep or you double. Now, really quickly, just to make sure you understand, and remember I said anytime you have a circle, you're going to have to do this out of 360. Since all 3 parts are equally likely, right, if you take 360 divided by 3, you should get all equal parts. Okay, and that should come out to 120. 120, 120, 120, right? Okay, so this is going to be 120 out of 360. This is going to be 120 out of 360. This is going to be 120 out of 360. Alright? Because all 3 parts are equally likely, so you just took your circle and you divided in 3s. Or you can do, if you don't like that, you can do 1/3, which is really the same thing, 1/3 and 1/3, right? Now in this one, you have, it should be easy, a half and a half, or 180 out of 360, 180 out of 360, and that should just give you a half and a half. Okay, so make a tree diagram of all the possible outcomes of spinning the 2 spinners. At the end of the branches on the far right, write the amount you would win for each combination of spins. Okay, here we go. So the first spinner, you're going to have 3 possible outcomes, right? There's your 3 possible outcomes. Outcome number 1, let's say 1/3, you get $100. Outcome number 2 is still 1/3, you get $300. And outcome number 3 is 1/3, and you get $1,500. All right. And then in your next one, you have 2 choices. You either get to double or keep, double, keep, double, keep, or double. And each one is 1/2, 1/2, 1/2, half, and then another half. Okay, so let's see. What are we going to get? We're going to get, if we go down this branch, right, we're going to keep $100. So we're going to end up with $100. Okay. On this branch, we're going to, if we get $100, we get to double. So that means we end up with $200 to go home with. In this branch, if we spin 300, we get to keep $300. And then this one, 300, we get to double 300. So 600, 1,500, we get to keep it. Or we get to double it, which gives us about $3 grand. Okay, so that's how, these are the possible outcomes. That's what I was asking in part A. What are the possible outcomes of spinning the 2 spinners? The possibility outcomes are, you get 100, you get 200, 300, 600, 1,500, or, I'm sorry, 1,500 or 300, or just 3,000. Okay? Okay, next one, it says, are each of the outcomes in the sample equally likely? And that's probably, I don't know, let's see. Okay, so the way to figure that out is to multiply the branches. So we have 1/3 times 1/2, that gives you 1/6, right? 1/3 times 1/2, 1/6. 1/3 times 1/2, 1/6. And the answer to the question would be yes. Since they all have 1 in 6 chance of happening, they are all equally likely. Okay, so let's go on to part C. What is the probability that you will take home $200? Okay, well, if we look on here, $200 would be, okay, right here you go. So you take home, so you have a 1 in 6 chance of getting $200. What is the probability that you would take home more than $500? That's not including 500, because first of all, we don't have anything like that here. But more than that 500 would be this one, and this one, because everything else is less than. So we have 1/6, 1/6, and 1/6. So altogether, you would have 3 out of 6 chance, or basically 1/2. Or 50% of the time in this game, you're going to take home more than $500, which is actually a pretty good game. What is the probability that you will double your winnings? Okay, so then we go back and we count up the ones where we doubled. We had 200, we had 600, we had 3,000. Those were the 3 that we had that doubled up. So if these are the ones that doubled up, that would be 1/6 plus 1/6 plus 1/6. And again, that would be 3 out of 6, or better known as 1/2, or better known as 50% of the time. Okay, and then does the probability that you would double your winnings depend on the result of this first spinner? No, not really. It depends on the second spinner, not really the first spinner. Okay, and then what if the amounts on the first spinner were 100, 200, and 1,500? Okay, what is the probability that you will take home $200? Justify your conclusion. So let's say it was 100, 200, and 1,500. So I'm going to take the 300, cross it out, and say 200. So now would be, we get to keep $200 or we get $400, right? So now the probability would be, there's two spots where it could be $200 that we take home. 1 out of 6 and then another 1 out of 6. So that would be technically 2 out of 6 or 1/3. Good? Alright, and I'm going to stop here for this video. Sorry it's so long. The other one's probably not going to be just as long as this one.